Now previously we were looking at factorising quadratic trinomials where our a value is equal to 1. But that's not always equal to 1, and it's not always easy to factorise by a highest common factor to make it equal 1. So what do we do when our a value doesn't equal 1? Well, there's a variety of strategies, but I'm going to have a look at what's known as the cross strategy. So let's take a problem. Let's say we had the following trinomial. We had 2x squared plus 7x and plus 6. And I wanted to factorise this trinomial. Well, the first thing I look at, and you should always look for, is a highest common factor between our three terms. And here I can't see any highest common factor that's going to come out nice and easily with nice numbers. So I move on. And what I notice here is I can't use the sum and product method or strategy because our a value is now equal to 2. So we can't make it equal 1 by removing a highest common factor. Well, not easily anyway. So what do? Well, one strategy that I like to use is known as the cross method, which is a bit of trial and error, but it helps put down your thoughts and to work out what combinations might work. Now, the cross method works by doing the following. First of all, I create an x column. Now, I know that when I put this into brackets, so I'm putting this into brackets like this, I know that when I multiply the first together, it should equal my first term. So it should equal 2x squared. So that means, assuming of course that these two terms are both x terms. So that means that I will need to multiply these two together and it equals 2x squared. Now x times x won't equal 2x squared. So two numbers have to multiply together to equal 2, or our pronumeral of x squared. In this case, there's only one combination that really works nicely, which is 2 and positive 1. Or you could use negative 2 and negative 1, but I'm just going to leave it as both positive for the moment. So let's put 2 and 1 down, because these are my factors of a. Now, in this case, I've only got one combination, which makes it a little bit nice and easier for us. So now I look at, with my next column, what are two numbers that multiply together to equal a constant? So what are two numbers that multiply together to equal 6? And let's just pick two. Let's just pick 3 and 2. Let's start with 3 and 2. 3 and 2 will multiply together to equal 6. And what I now want to do is, when I multiply this together, let's just say I had 3 in here and 2 in here for argument's sake. What actually happens is the 2x multiplies with this 2. So this 2x will multiply with this 2. So what I'm going to do is I'm going to cross multiply here and go 2 times 2 will equal 4. And then my x will multiply with this 3. So my 1x will multiply with this 3. So 1 times 3 will be equal to 3. And what I'd then do, those two would add together because that'd be my like terms. So I now need to add these together to see whether my sum is equal to my b value. Now 3 plus 4 here does equal 7. So I've happened to have gotten the right combination right away. And that combination is 2x plus 3 and 1x plus 2. Now to think about this, what I'm essentially now doing is just bracketing the top and bracketing the bottom. And this here goes into my first linear factor here. So it'll be 2x plus 3, because it's positive 3. And over here, it'll be 1x, or just x, plus 2. Now from here I can always check to see whether this will work. So let's check this now by multiplying out our brackets. So let's just rewrite this, the 2x plus 3, the x plus 2. Now when I multiply the first together it'll be 2x times x, which will be 2x squared. My outers will be 2x times 2, which will be plus 4x. My inners will be 3 times x, which will be plus 3x. And then my last will be 3 times 2, which will be plus 6. And as I collect the like terms, we'll have 2x squared plus 7x, and then plus my 6 at the end. And what we've arrived to is the same expanded solution that we began with. So our factorising here has been done correctly. Now in this example that I gave you, I was lucky enough that I was able to find the correct combination straight away. And that's not always the case. Part of this is a bit of trial and error. So if you didn't get the sum correct the first time, you'd rule a line underneath and you just keep going. You'd try a different combination. Now, something that's really important to check is sometimes the order that those two go in matters. So if I had the 2 at the top, 1 times 2 would be 2, where 2 times 3 would be 6, 6 plus 2 would have been equal to 8. So that combination wouldn't have actually worked. So part of this is you might need to flip this. And sometimes you might need to change what factor numbers you're actually using altogether.